Hello, and welcome to math class. Today we're going to be looking at triangles and talking about what type of side lengths can make a triangle. And you have a warm-up here. Your warm-up says to use the coordinate plane to determine each distance and show your work. So just as a quick illustration of what that's talking about, the first question here asks me what is the distance from point F to point D. So that, let's see, here's F and here's D. And so what that question is asking is essentially how long is that segment? It's easy. I just have to count the squares. Let's see. 1, 2, 3, 4. That has a length of 4 units. So for your warm-up, you're going to do that for number 1, number 2, number 3, and number 4. Pause the video and hit play when you're ready to talk about today's learning goals. You've hit play, so that means that you're ready to talk about this warm-up. As you can see, I have labeled the side lengths here. And now that we've figured out those distances, let's talk a little bit about today's learning goals. We have 2 of them. First, we want to use patty paper to investigate triangles. Next, we want to construct triangles. That means we want to make some triangles from 3 angle measures or side lengths, identifying when the conditions determine a unique triangle, more than one triangle, or no triangle at all. Our key term today is the triangle inequality theorem. And here's our essential question. You know how to draw a triangle. If I said draw your very favorite triangle, you could draw any triangle, and it wouldn't take you any time at all. It would be easy. But here's the question for today. Can you construct a specific triangle if you were given only 2 or maybe 3 possible side lengths? Is there more than one possible triangle that you could construct? So if I told you how long the sides have to be, could you make a triangle then? How many different triangles could you make? That's what we're going to be talking about today. Now, before we get too involved in today's lesson, I have some questions for you to think about with a partner. What I want you to do with your partner is classify each of these statements as either always true or sometimes true about triangles. So for example, you guys know that triangles have 3 sides. So you could say that a triangle always has 3 sides. You know that some triangles are acute, not all of them, but you could say some triangles are acute. It's sometimes true that triangles are acute, but not always. Triangles always have 3 sides. Triangles are sometimes acute. So that's the difference in the way that we're going to classify triangles in this exercise. Your task is to read these statements on numbers 1, 2, 3, and 4 and decide with your partner, is that statement always true? Or is that statement only true sometimes? Okay, pause the video, set a timer for 4 minutes. The teacher is going to be walking around the room and checking to be sure that you understand and listening to the conjectures that you and your partner are coming up with. Press play when you're ready to talk about these statements. You've pressed play, so that means you've been talking for about 4 or 5 minutes about these statements. Now let's talk about them together as a class. The number 1 says that the angles of a triangle have the same measure. This is sometimes true. In fact, we have a special word for when this is a true statement. If a triangle has angles that all have the same measure, we call that an equiangular triangle. You could also call it an equilateral triangle, because any triangle that's equilateral is also equiangular. And we'll talk more about that later. Now, what about the angles of a triangle? Statement number 2 says that a triangle has 3 angles. That is always true. All triangles have 3 sides and 3 vertices and 3 angles. This statement is always true. 2 sides of a triangle have the same measure. This is sometimes true, and I bet you know the name of a triangle where 2 of the sides have the same measure. That's called isosceles. Like that. When you have 2 sides that are the same, that's an isosceles triangle. So some triangles are isosceles. This statement is sometimes true. One triangle of an angle measures 90 degrees. Again, this is sometimes true, and those are called right triangles. So a right triangle has one angle that measures 90 degrees. We always represent that angle using a little box. The box tells us that this angle right here has 90 degrees. And that's what makes that triangle a right triangle. So in classifying the statement, we had sometimes, always, sometimes, sometimes. And doing this task gave us the opportunity to review some of our key vocabulary: equilateral, isosceles, and right. And we also decided that the word equilateral and the word equiangular both describe the same type of triangle. That would be a triangle where all the sides are the same measure and all the angles are the same measure. So up next, we have a little bit of an investigation for you to think about. Let me read you a scenario, and I wonder what you're going to think. Our scenario says, Sarah says that when you know two segment lengths, you can form many different triangles. She claims that she can also use any three segment lengths to form a triangle. Sam does not agree. He thinks that some combinations will not work. Who is correct? Use a counterexample to disprove the incorrect statement. So let's just review what each person in this scenario is saying. Sarah is essentially saying that any three segment lengths can form a triangle. Sam says, there are some combinations that will not work. Your task right now is to decide who's right. Will any three segment lengths work? Could I just choose any three numbers and those could be the side lengths of a triangle? That is what Sarah says. Sam, on the other hand, says, no, Sarah. There are some side length combinations that will not work. You can't make a triangle out of those. Is he right? What I want you to do is set a timer for 2 minutes, pause the video, and talk with your partner. Make a decision. Who do you think is right, and why do you think they are right? Your teacher is going to be listening to your conversations, and once everybody has had a moment to talk with their partner, you're going to discuss as a class what you think about this scenario. If you've hit play, that means that the 2-minute timer has rung. 2 minutes is up. You've been talking with your partner about this scenario, and you have some ideas about who's right and who's wrong. At this point, we need some people in the class who think that Sarah is right to explain why. Pause the video and let your classmates explain. Excellent. Now that you have heard your classmates talk about why they think that Sarah is correct, let's hear from somebody who thinks that Sam is correct. At this point, we need somebody who thinks that Sam is correct to explain why Sam is correct. Okay. Thank you for sharing your thinking with your partner, and thank you for sharing your thinking with the class. We are going to revisit this problem later, and we'll actually see what the actual answer is. But for now, we're just going to table that and sort of put that in the back of our minds and just know that we're going to come back to it. At this point, we're going to take a break from our Carnegie books for a minute to just look at a simulation that lets us see what sort of side lengths can we use to make a triangle and which ones may or may not work.